Hey, what's going on everyone? In this video I just want to go over the multi-stage amplifier design. So in a real-world design you want to keep the gain for each stage around anywhere from 10 to 100 gain of voltage gain, right? Ideally you actually want to keep this in lower, 10 to 20 per stage of voltage gain. So let's do an example. So here's your input voltage. It goes in the first stage, and then you have some more gain stage here, and then you have your last gain stage. And you have V out. So input, if you have a voltage input, typically you want a high impedance, Zn to be high as possible, and the output impedance you want to be low as possible. All right. So how you do get a high input impedance using a non-inverting configuration. Usually a JFET or a MOSFET input is ideal for that because there's no very little current going to the MOSFET or JFET input terminal. So here is a non-inverting configuration with gain resistors, and then it's going to pass on to the next stage. And here you can set more gain in if you want to terminate this with an inverting and you want to keep the gain positive overall, then the next stage would be an inverting also. So let's try that. So for inverting, for the middle part, right now I'm ignoring all the bias resistors, but you might want to consider that also. Remember, ideally you don't want to use that if you don't have to. So keeping all the resistor values low at a reasonable range, then you can avoid using bias resistor altogether. So this, your third stage is another inverter. So I'll call this one R3, R4, R5, R6, and this is a V out. And usually you want to end your amplifier design with a low pass. So here you add a cap. So your low pass pole will be set by 1 over R6 times C. Right? It's a low pass. Here's the Bode plot. A rough Bode plot. F, and this is H. Alright. So one of the big mistakes is that people want to assume that they want to save power or whatnot and choose ridiculously high resistor values, and the performance can be degraded if you use high resistor. I would recommend use anywhere from 1K to 10K, maybe up to 50K if you want to do a really good design. Yes. Let's see. And the reason why, I haven't explained this, but the reason why you would use small gains per stage and versus a single stage amplifier is because you want the higher the gain, there's a thing called the gain bandwidth product, and it's a product between the gain and the bandwidth at unity. This has to do with the fundamental concept of gain bandwidth product and a single amplifier from first principles. So basically it tells you that there's a trade-off between gain and bandwidth. And if you keep another thing is, if you keep your gain low, you can have more bandwidth. But that's the first thing. The first thing is bandwidth. The second thing is that your loop gains also depends on your your gain. So the lower your gain, the higher your loop gain. Loop gain is defined as A, which is the open loop gain, times beta, which is the feedback factor. The higher the gain, usually, gain with feedback is defined as A over 1 plus A beta. This is the loop gain. Let's assume you have an ideal op-amp where A is very high, the open loop gain is high. The feedback is equal to 1 over beta. So the gain, the closed loop gain is 1 over beta. So the higher the gain you have here, the higher the gain here, the lower the feedback. And the lower the feedback means that your loop gain, let's call this T, is low. So AF high means low beta. So that means small, the loop gain gets smaller. When loop gains get smaller, your op-amp becomes less ideal. So ideally you want to keep the closed loop gain small so that your loop gain is high, so that you have ideal performance for the op-amps here. Alright, thanks for watching.